Taste is a complex trait, like many other traits, like height or weight or the color of the skin. And this means that is a composition of environmental factors and genetic factors that is behind this sensation of taste that we have when we eat some, or when we try some food or some drinks or something like that. So and there is a mixture of cultural factors, which are the environmental factors, and genetic factors. And we know already that there are several genes that are involved in the perception of taste, but still there are many others that have to be identified. And this is what now can be done by analyzing the genetics and the genomics of taste in different populations. There are several examples of genetics of taste that is different between different individuals, and one is the taste of bitter, or so that some people like coffee and some people do not like coffee. Some people need to put a lot of sugar in the coffee, and some people can drink coffee without any sugar at all, or also the same thing with chocolate, bitter chocolate, or chocolate that, you know, that has to have many additives like sugar or milk and so on. And there is a wide variability in the population. And we know that there are genetic changes in specific genes that are related to these differences in the people that like coffee and people that do not like coffee. The genetics have played an important role in the evolution of many of the traits of humans and other mammals. And in the case of taste, it seems clear that the adaptation to different environments have been very important, especially because there are some foods that also, there is some food that may have some dangerous components. And so especially many of the components that are present in some of the foods have the bitter taste, and likely the different composition of the human population in the perception of the different components of the food, and especially the bitter elements, have been something really crucial in the evolution of the taste perception. It seems clear that there are differences because we know that there are some geographic regions where people are eating things that are very spicy, and in others in which, you know, the people do not eat things that are spicy, and the perception to spicy things or to bitter things is different, and this likely has to do with adaptation to different climate conditions, to the availability of some elements that were present in some cultures that were not present in others, and also to the food that is available in one geographic region that is not available in another geographic region. But we still know very little about that. The genetic of food taste, or the taste to different food and different elements, will have an important impact for health. We know that there are many disorders for which, you know, obesity and feeding is really very important. One is obesity, the other one is anorexia and bulimia, and a very good knowledge about the taste preferences of the population and of the different individuals in different geographic areas will be really very important for this, and to prevent and perhaps to cure or to treat or to make an important impact on how we are dealing with this disorder.
Taste perception is a mixture of cultural and biological components with a strong genetic component. We can distinguish, for example, in terms of bitter perception, between non-taster, medium taster, and super tasters. And these differences are definitely derived by the presence of different mutations within one specific gene, which is a taste receptor gene. Taste perception can be analyzed at the, let's say, phenotypic level using different approaches. For example, you can taste bitter perception using compounds stimulating bitter perception and using specific pieces of papers and distinguishes among different individuals. Or you can directly analyze the genes involved in taste perception and looking at the mutations and the differences within the coding region of these genes. Taste perception is extremely relevant in defining liking and disliking of foods, of course, and the food choice has a lot of relevance thinking to health status. So we can identify different diets, different food selections according to taste perceptions. In terms of bitter perceptions, as I mentioned before, we can distinguish in between non-taster, medium taster, and super tasters. Non-tasters have a very low perception of bitter compounds, and usually they like any kind of food, and they, for example, had a lot of oil to the salads. And usually, non-tasters develop an increase of BMI, which means body mass index, overweight, according to age. On the other hand, super taster usually dislike a quite large series of different foods, and these could have also implications for in terms of health. For example, they don't like cabbages and vegetables. And this could have implication in prevention of cancer. We will start collecting samples across the Silk Road, an extremely interesting way of exchanges of cultural and aspects, as well as genes and so on, as of course of goods. And we will also carry out specific evaluation of taste and taste perception and food preferences across the Silk Road. And at the end, we will match the cultural, the phenotypic, and the genetic information all together, trying to identify which are the basis of food choices and food taste and food preferences in this peculiar area of the world.
Well, there are many interesting physical processes involved in cooking, and as a soft matter physicist, I'm very fascinated by changes in phase, so how a material transforms from a liquid state to a solid state. And this can happen extremely easily with soft materials simply by subjecting the material to mechanical force or just by changing the temperature. So a great example is when you take an egg white, which is a liquid, just by whipping it or beating it, you can turn it into a solid, which is a completely different, has completely different properties. There are, of course, many basic states of matter that you'd learn about in high school chemistry, such as liquid, gas, and solid. And in cooking and in the kitchen, there are myriad materials that are combinations of these basic phases, but completely different phase. So, for example, in emulsion, you can take two liquids and mix them together, and they become a solid. Or a foam, which is composed of a liquid entrapping air, has solid properties. So you might be referring to, for example, microbes such as yeast and bacteria, which are cells that play a unique role in altering both the taste and flavor as well as the texture of foods. And so in the process of fermentation, these cells, bacterial and yeast cells, can secrete or produce compounds that affect the flavor, but also, interestingly, the texture. So by producing gas as well as large molecules that alter the viscosity of a material, in addition to lowering the pH around these cells, this greatly alters the texture of food. So, for example, yogurt is produced from liquid milk simply by the acidification that's generated by these microbial cells. Well, there's a very intimate relationship between technology and cooking, and I think that advances in technology can drive new inventions and discoveries in the kitchen, and vice versa. So an excellent example, for example, is the refrigerator, which I think the invention of the refrigerator totally changed the way communities eat and plan their meals. And so this is happening all the time in the technological developments come into the kitchen and enable us to cook and eat in an entirely different way. Well, this is a very exciting collaboration between Alícia and Harvard, and as a physicist, I'm very excited about it because I think that food is an excellent way to educate students about the properties and materials of soft matter. And so food is something that everyone can relate to and has a lot of experience with. And so by using this as a tool to teach students basic concepts in physics, I think that they're going to get a lot out of this course. There will also be a series of public lectures associated with the course as well, so that the word will get out to a broader audience, even the relationship between science and cooking and how we can learn so much about science through food.